In the previous chapter, we have seen how to use interfaces in Java. And one of the most known interfaces in Java is a collection. It contains basically all the data structures that are pre-built in Java. One of these data structures is the array list. By the end of this chapter, you will understand how to use the collection interface and what is the hierarchy behind this interface. So what are the classes and the interfaces that are derived from collection. And also we will see how to use the ArrayList class. The only data structure that may contain different objects that we have seen in this course is the array. And we said that while declaring an array, we have to say its size. And this size cannot be changed after that. Also, if we want to insert or delete or search for an element in an array, we need to write our own code. There is no pre-built method that can be used. To overcome these limitations, Java offers a rich framework called collection. A collection, as its name implies, is a group of objects. Java Collection Framework consists of a set of interfaces and classes which helps in working with different types of collections, such as lists, sets, maps, etc. These ready-to-use collection classes solve lots of very common problems where we need to deal with group of objects, as inserting an element or deleting an element, searching, sorting, or any other operation that you can have in a collection of objects. As you see in the figure, the interface collection has three sub-interfaces, which are set, list, and queue. A set is defined as a group of unique objects. What is considered to be unique is defined by the equals method of the object type it holds. In other words, a set cannot hold two equal objects. A list is defined as a sequence of objects. In contrast to a set, a list can contain duplicate entries. It also keeps its elements in the order in which they were inserted. A queue has two sides. Entries are added to its tail end, while entries are removed from the top, or what we call the head. This is often described as first in, first out. Java also offers another interface called map. In a map, we can store pairs of key values. So in order to store any value, a key must be supplied along. It's like the associative arrays that we have seen in PHP, for example. For the sorted set and sorted map, we will print their stored element in ascending order. In this figure, you see the hierarchy of classes and interfaces extending or implementing the collection interface. For example, for the interface list, we have two classes implementing this interface, which are ArrayList and Vector. And the rest of this chapter will be about how to use the ArrayList. What is collection in Java? Is it a group of objects, a group of classes, a group of interfaces, or none of the mentioned? The answer is a group of objects. Collection is an interface which represents a framework to have or to model a group of objects. List, set, and queue are what compared to collection? So, should we add the word extends, implements, both of the above, none of the above? What is the right answer? It's extends. List, set, and queue are all interfaces that extend the collection interface. Another question. Which among the following maintains the insertion order of the element? List, map, queue, and set. The data structure that maintains the insertion order are both list and queue. For the map and set, we don't have an order while inserting the elements. We don't know in which index each element is inserted. Which among the following doesn't allow insertion of duplicated elements? List, ArrayList, set, or vector? The right answer is set. In a list or array list or vector, we can have duplicated elements. In a set, each element should be unique. The ArrayList class implements the list interface. And in order to include it, you should import java.util. As we said, for the arrays, the regular ones, the size is fixed, so we cannot exceed the size or we cannot reduce the size if we delete some elements. While for the array list, we can have dynamic arrays that grow as needed. The array list size can increase or decrease if we add or delete some elements. We can also create the array list by defining its initial size, but this initial size can be changed later. So it can automatically be enlarged or reduced. In order to create an array list, you should create a variable of type ArrayList and then call the constructor. The constructor can either take no arguments or it can take the size of the array list, which is just the initial size. In this slide, you have some method of the class ArrayList. For example, in order to add an element, you have a method called add, and you will give as an argument the element or the content of the element to be added. To get the size, I have a method called size. To get the content of a predefined cell inside the array list, you need to call the method get and to give the index of the element. In order to remove an element, you have a method called remove, and you need to give also the index of the element to be removed. We have other methods, as for example isEmpty, that returns either true or false if the array list is empty or not, clear, that deletes all the elements inside an array list, a method called toArray that converts an array list to a regular array, and we have also a method called set that takes as an argument the index and the element to be added in this index. In the previous slide, we didn't precise the type of elements inside the array list. So we can include different types. We can have an array list containing strings, integers, some object from a certain class like students or whatever. Okay? We can also precise what is the type while declaring the array list. And this is done through the generics. In Java 1.5, generics were introduced, which allowed us to parameterize the type arguments for classes, including those in collection API when declaring or constructing objects. In a generic collection, we specify the type in angular braces, as it's done here in the first statement. So this is called a type parameter or a generic class. It allows the same ArrayList class to store lists of different types. For example, if we want to have an array list of strings, the declaration should be as follows. So if we compare the array versus the array list, we can first say that the array list size grows automatically. Also, the array list works with the generics, so you can have an array list of strings or any other class that you have created. The type you specify when creating an array list must be an object. So in order to do an array list of integer, the following statement is not allowed. So instead of the primitive types, Java offers some classes that we call wrapper classes. They replace the primitive types with some predefined classes. For example, for the int, it will be replaced with integer as a class. You see in this table the different wrapper classes that are predefined for the primitive types. For int, for instance, the wrapper will be integer. For double, you have a class called double with an uppercase. For char, it will be character, and for boolean, it will be boolean starting with an uppercase. You have also an example of an array list containing doubles. So you can see that once you construct the list, you can use it with primitive as normal. You should use the method get and give as an argument the index of the cell to be retrieved. For looping through an array list, you can just do a for loop and start with the index 0 to the index the size -1, and you can get the size through the method .size. In order to search an element in an array list, you have a method called contains. You give it as an argument the element that you are searching for, and it will return either true or false. If we were using regular arrays, we have to write our own code as we don't have any method that is offered in Java to search an element inside a regular array. I can have an array list as an attribute inside another class. For example, here I have a class course and I have an array list containing the student names. Now each object will store a collection of data inside it. This is called composition. To iterate over an array list or any other collection, you can use either the for like we have done in the previous slides, or we can also use the iterator class. Let's follow this example. So here we first created an array list of strings, and then we added some values using the add method. Then, in order to be able to iterate over this array list, we created an instance from the class iterator. It will take as value the list.iterator. Then we have a loop, the while loop, that will iterate over this array list while the method has next returns the value true. Another way of iterating over the array list is to use the for each loop. So here we have the same example of the array list containing some strings, and we used the for loop in order to get all the elements inside the array list. In this slide, we will summarize what are the methods that are predefined in the class ArrayList. We have first the method add. We give a value or an element to be added, and it will be added at the end of the list. We can also use the add by precising what is the index and the value. In this case, the element will be inserted just in the given index, and we will shift all the subsequent values. The method clear will remove all the elements of the list. The method indexOf will return the first index where given value is found, and it will return -1 if this value doesn't exist in the list. The method get returns the value at given index. The method remove takes an index as an argument, and it will remove the value at the given index, and it will also shift the subsequent values to the left. The set method takes as arguments the index and the element to be modified, and it will replace the old value by the new given one. The method size will return the size of the list. The method toString will return a string representation of all the elements inside the list. The method addAll takes a list as an argument, and it will add the new list to the end of the current list. The method addAll takes an index and a list so that the new list will be added in the precised index. The method contains searches an element inside the list, and it will return true if the given value is found and false otherwise. ContainsAll takes as an argument a list of elements, and it will return true if the current list contains every element from the given list. The method equal, it will return true if the two lists contains exactly the same elements. We have the method iterator and list iterator in order to be able to iterate over the array list. The method lastIndexOf takes an element or value as an argument, and it will return the last index where the value is found. The method removeAll takes as an argument a list, and it will remove all the elements found in the given list. The method retainAll will do exactly the opposite of removeAll. So it will remove any element that is not found in the given list. The method subList takes two indexes, the start and the end indexes, and it will return a new array list, which is just a sub-portion of the original one. Let's take this example. So we created an array list and then we added 3 items. Will this compile? Yes, assuming that we have imported the java.util.ArrayList. Let's take a second example. Here we have a variable list as an array list, and then we added 1, 2, and 3. 1 or 2 are strings, while 3 is an integer. Will this compile? Yes, all are added as objects. So here we will have heterogeneous elements inside the list. This is another example. We created an array list called list with an initial size of 3. Then we added 4 elements. Will this compile? Yes, the array list size can grow dynamically. In this example, we created an array list having an initial size of 4. Then we added these elements, which are 1, 2, 2, and 4 as strings. And then we did system.out.println list.index of 2. Will this compile, and what is the output? Yes, it will compile. The index of is a method that takes a value and it will return the index if this value is found. We have the value 2, which is an element in the index 1, so the output here it will be 1. Here we have the same example. We just added the for loop in order to print the content of the list. Try to read the code and say if this will compile or not. No, we will have an error. We will have an exception as we exceeded the size of the array list. The array list contains only 4 elements and we are looping from the index 0 to 4, and the last valid index here should be 3 and not 4. So we will have an error, which is index out of bound exception. What we do if we need to fix it? We need just to change the loop for the upper bound to 4 instead of 5. Let's take another example. Here we have an array list called R1 and a second array list in which we will assign the reference of R1. Then we added an element, which is a string here, to the first array, and we displayed the message if the R1.length is equal to R2.length or not. So would this compile, and what is the output? We will have an error because we don't have a method called .length. We should use the dot size instead of the dot length first. Okay, we assume that we change it to dot size. So what is the output? Would it be true or false? Are the sizes equal or not? Yes, the result is true, because both arrays here, they are indexing the same reference. So R1 and R2 are equal. We have a second example here. We created two array lists, R1 and R2. Then we added the string test to the R1 array list, and then we added an element to the R2, which is the R1.getZero, that will return the same string, which is test. So by the end of the statement, both array lists will contain the word test. The next statement is R1 of 0 is equal to test1. This will generate an error because we are not allowed to use such statement. This can be only used in regular arrays and not an array list. So it should be replaced by r1.add test1. By the end, we printed out the content of the first index in R2, and the result here will be the word test.